So we saw some idea about how these objects interact and could have some concurrent procedure calls for these scores and class teacher and physics teacher and all that. So I'm wondering, I'm sure that we have this other data set like shopping bills. So we have these customers and we have shops. So again, there are a lot of things happening there, right? People are going, same customer is going to a shop, shop is getting.
Interesting difference. Huh? The difference is that unlike there where the class teacher and physics, chemistry, maths teacher could be under the class teacher. Here you can't make one customer under another customer.
Correct. So the customers are all separate from each other, and the shops are also
level.
Yeah, they are all at the same level. They are all equal in some sense, equal standing.
Shop also is the same.
Yeah, because I can't say that this shop will create another shop and I can only go to that shop through this.
Or
shop.
even the shop creates a customer.
Yeah.
Or the customer creates a shop. Nothing like that.
So they are independent.
They are all independent.
Yeah. So we have.
So we have many customers.
Yeah, we have many customers and we have many shops.
They are all objects.
They
all got traded.
Yeah.
Okay. And then the customer keeps going and buying. Why does the customer keep buying from the shop? Because he has some things to buy, right? In his house something is happening.
Yeah. But obviously you don't go to the shop every 5 minutes or something.
No,
right?
you don't do that.
So you wait for something to happen.
Typically in a house, people keep having requirements. So get me a packet of biscuits.
Yeah.
Or something else. Somebody, sugar has run out, so you need sugar or something.
Yeah. So maybe let's have a systematic way of doing that. So maybe they have a list which they put up somewhere. Maybe they have something
stuck on the fridge.
Stuck on the fridge, for example, with a magnet. Right?
Or you have a book.
Yeah, or you have a book. So you are one person. You open. You go to the kitchen and you say, oh, there is no sugar, or there is no biscuits, or there is no something.
Or we need milk or curd or something.
So you will
go write down on that.
You will go and write it down because you are lazy to go and then when there is enough things on the list, then somebody will go.
Somebody has to go. Some poor fellow has to take it.
So we have this house. List. Yeah. So we have this house.
That's like a what that looks like that producer whatever I said, no producer consumer something.
Yeah. So exactly. Huh? So we have a list here. Right. So we have the shopping list inside this house. Yeah. So we have this house.
Nice house.
And we have the shopping list. And so various people are adding things to this list.
Everybody keeps writing into that list.
Yeah. And when the list becomes long enough, then somebody decides to take the list and go to a shop.
Goes to a shop.
Right. So now I have a shop here.
So when we said Srivatsan went to Big Bazaar or something like that, the result of Srivatsan going to Big Bazaar was this process that happened inside his house.
Correct.
Okay.
So this guy will come here and it will say, give me these items, right? Whatever is on my list.
On the list.
So then
you may ask the shopkeeper, you may give the list to the shopkeeper may do.
Yeah. So let's assume it's one of these old style things.
Kirana stores.
It's not a department store where you pick it up on the shelf. You give them a list, they'll go back, they'll have some dark room inside and they only know that. And they'll come back and they'll give you everything. So luckily.
But better way actually ask me. Right?
Yeah. But now the same thing that happened here is happening here also, right? So this guy asked for sugar because somebody ate it. Now this guy has gone and picked up a sugar from the shop. Now the shop has lost one packet of sugar.
So shop has to.
So shop also has to get it, right? I mean, has to get it. Otherwise, eventually somebody will come and there will be no sugar.
So shop can basically, they'll have somebody to purchase, no, the shop.
Yeah, they'll have to go to some market or some.
They'll have to call
some supplier.
So whoever is making sugar, he will have to call the guy and
say deliver some. But again, he's not going to do it for everyone.
He won't do it one by one. So he will have a list.
So he'll have a list. So this is like a reorder list, right?
Which he will. I've seen actually in pharmacies and all, you go, he has a little book.
Yeah.
You could try to buy.
Correct.
Except give me crocin. He goes to the shelf. He'll see when he opens the box, takes out crocin.
Yeah. He'll say there only two strips are left.
2 strips are left. Then he'll open a book
and he'll write it.
And he'll write it down.
So basically, these things now, let's assume that when you sell these things, then you write down here saying I sold these things. So you know that these things used to be in my shop, but now they are not there anymore. Right? So now another guy might come from somewhere else. Right? Another customer and he might produce another list like this. So now you will add these items also here. Right? And eventually when there are same thing, lazy guy like this guy didn't want to go and buy one thing at a time. So he only goes when the list is long enough. Reordering also, you will not reorder only one item.
You'll wait.
So eventually this will go out to some supplier.
One or more, depending on the items.
Depending on the items. and the supplier will eventually give back that quantity of items which have been used.
Phenomenal amount of concurrency going on here. Every customer, so every house is generating items and putting it on the list.
So these lists are being generated by some producers. So this is the second house here, another house. Let's draw it nicely. Okay. So this is another house.
So many lists are getting generated.
So these lists are happening concurrently because different people are writing into it at different.
So the rights are there. People are putting requests into the list.
Yeah.
Then at some point,
that list gets transferred to the shop by somebody going.
Somebody takes. That's the bill.
That's the bill.
That is where the bill comes, right?
Yeah.
All we know is the bill.
Yeah. The bill that we saw in the data set is
without a date and time.
Yeah. Is actually the outcome of one such transaction.
One such transaction. Yeah. So it's a result of this process. Some people put something on a shopping list. This guy took that shopping list, went to the shop, he made an order, he got the result, and then he took the bill and went out. And that's the bill we are seeing.
Yeah.
So each bill got generated by one process like that.
Yes.
And that bill in turn generated.
Yeah. So let's look at our bills just to remind ourselves that they exist. Right? So these are our bills. So each of these is the outcome of one such interaction between.
So in this case, the customer is Ahmed.
Yeah. So Ahmed,
presumably in his house had a list.
Yeah. And he went to the list, this SV
Tomatoes,
stores, and said,
cupcakes, carrots, and all that were put on that.
Yeah.
He went to SV stores, who's a shop.
Yeah.
He bought all these things.
Yeah. And SV stores now made
a note. SV stores recorded these things.
The bill is added to its reorder list.
Reorder list.
Saying I have just got, I've given away so much of these things, so I am down by that much in my stocks. So eventually I must replenish
the
stock, otherwise customer will be unhappy.
So we have, basically every shop is getting many customers.
Correct.
Now they can service one customer at a time, more than one. Usually in the old Kirana type store, only one at a time.
One at a time.
So the customer themselves will be in a queue.
They will be in a queue.
Huh?
Yeah.
Customer makes request from the shop, so they will be in a queue. So again producer consumer model. Shop is the producer.
Yeah.
Customer is the consumer. Consumer stands in queue, and then the producer basically will serve the customer. After serving the customer or while serving the customer, will keep entering into the list, reorder list. Somebody else in the shop is looking at the reorder list
and deciding when to place an order.
the order. He goes, places the order on some suppliers, more than one supplier. That supplier takes his own time, and then presumably he will bring it in a truck and he will have a place to put it, the result.
Correct.
So there is a tray, equivalent of tray there.
Yeah, there is a tray for the supplies to come.
Supplies to come. So the supplier will come and put the result in, put it in the godown, something he will do. The shop will take the godown items and he will stack it again in the shelf, something he will have to do inside. Meanwhile, more customers are coming. So a lot of parallelism, lot of things going on simultaneously. Concurrency like anything.
Yes. And now you could have problems, right?
What problems can you have?
So this guy, because supposing
we took care of the problem, tray and all that.
Yeah. But what if
atomicity, read something, right?
No, but in terms of the shop's own stocks.
Okay.
So he has a policy. Maybe he has a policy that when this reorder list becomes long enough, he will reorder the things. But there's an unexpected. It happens. Some festival day, everybody wants to buy something.
Okay.
Sugar,
flowers,
peanuts, something.
Peanuts. Okay.
Some particular thing which has to be made that day. So there's a big rush. Normally it doesn't matter. Normally he knows that this reorder list is when it fills up, and if he fills it up, reorders, it's fine. But today, all the customers
bought sugar and went away because Diwali.
And
there's no sugar left.
And suddenly the next guy comes. Yes, there's a pending order. I mean, eventually 20 bags of sugar are going to come.
But right now
there's nothing.
What happens then?
So then what happens? So
customer comes with a list. One of the items is sugar. Shop doesn't have sugar.
So what will the customer do? Well, the customer wants the sugar. So he knows.
Shop can say like, wait, my guy has gone to shop. Go on to buy sugar. He can expedite. He can try to.
So he can try and push the supplier to come early, but maybe it is like late evening and the supplier is definitely not going to come till tomorrow. So then you have, or even the customer may be smart enough to know that this is not going to happen, right?
Customer will typically say, forget it and go to other shop.
Yeah, he'll go to another
But in that shop, same problem may be there.
Same problem is there, but
festival,
this thing now, this guy has come to buy some 10 things.
Oh.
And the shopkeeper has
9 things he has.
9 things he has.
Only sugar he doesn't.
Only sugar he has, and he's going to lose a customer for all things.
No, what I have seen is, at least I have seen this in Bombay and all. I'm sure here also, Chennai also it might be happening, right? The shopkeeper never sends the customer out. He will
Yeah,
go.
yeah, he will try to hold him. He will try to hold him. So he will say, "I'll get it for you." Yeah.
He'll go to another shop.
Yeah, and
He'll send his boy. He will send to another shop.
yeah, to pick up that same item.
Sugar.
So he will behave like a customer in some sense for that shop, and just pick
He'll
up
buy
the,
sugar.
the missing items. He'll buy, come back, and then
Put the whole thing together. And meanwhile, he keeps the customer happy. Chatting with him. Huh?
yeah. So
Something like that.
Yeah, exactly. So filling this order of the customer, preparing the bill, which is essentially.
There's another thing you can do, right? The shop can say to the customer, I have 9 items, buy the 9 items. Sugar will come shortly. When the sugar comes, I'll give you. No?
Yeah.
Give me your number, I will deliver it in your house, he can say.
Yeah. So that depends on whether how urgent it is for the customer, right? If the customer is
Going to go make sweets.
if he's already, if the tea is,
if he's got guest sitting in his house and he's got no sugar in his house.
yeah.
Huh?
So the tea is boiling and
He
he
is
needs
boiling.
it.
That is true.
So he may not be happy about this.
He may not be happy about giving the number and all that.
Yeah. But this, so one has to
So
account.
a lot
but
of possible things come up because of concurrency.
Yeah, there are situations which you may anticipate like this.
Huh.
And there are some which you may not anticipate.
And
also.
there are solutions for it also in real life,
Yeah.
it seems, right?
Yeah. So those which come up in real life, people have figured out they do happen, and then you make up a kind of solution which fits that.
Huh.
But you have to be careful that sometimes, okay, 2 customers come and there's 1 packet of sugar.
I can't break the packet, assume.
Yeah.
Otherwise I can tear the packet.
Yeah. So this guy is waiting because, okay, so supposing this happens, right? So he has come for his sugar. Now they're in a queue.
Huh.
So he's waiting, and that guy has said, okay, while you're waiting, I've sent my boy to get the sugar.
Huh.
And this guy has come, so he turns his attention to the next customer. That guy doesn't want to wait for this first guy's sugar to come, right? So this guy has asked for some tea or coffee or something. And the last packet of coffee is being taken by the previous customer.
Yeah. Oh, I see.
So now this guy has to wait for coffee, or that guy could say,
First guy is, the tea is there or coffee is there.
Yeah.
First guy is booked the tea and is keeping it.
he's
And
holding
waiting
on
for
to it,
sugar.
waiting for sugar.
The second guy is waiting only for tea.
Yeah, only for this. So this
After all that, the first guy might get frustrated and go away.
yeah, and this guy may also lose the second
This guy
customer.
may lose the second customer because he didn't serve. He could have actually served tea to the second
Yeah,
guy.
so he might take it and say, okay, you're missing 1 item, you might as well miss 2 items.
Really, really interesting possibilities.
So yeah, so a lot of such things you could imagine and think of how you could find a suitable solution which people will be happy with. Ultimately for the shop, they have solution they choose is the one that keeps the
algorithms
customer
or
happy.
whatever it is, this way of writing code for writing it for concurrent situations is phenomenally challenging. Huh?
Yeah, it's very challenging actually. Yeah, because of this
Possible.
Yeah, mainly because these things are happening, without any predictable order between them, right? So you don't know when the list is going to get, filled. So you don't know when the customer is going to come asking for an item, compared to when you are going to reorder the item and it's going to be delivered. So then you have a mismatch here between what is available in the shop and what is. So in principle you have everything, but some of it is in transit because the order has not come back from the supplier. And at that point, if a lot of customers come which you can't predict, then you have difficulties. So since you can't control in some sense also this order in which things happen, you have to have contingencies for all this.
Normally when I write a procedure, right, in terms of steps and so on, I can check it. I give it some data and I actually go through the steps.
Yeah.
I can validate. How do I validate some?
Yeah, so here you will have to in some sense imagine all the possible ways in which one could happen before the other. So it becomes the number of possibilities becomes very large.
Very
right?
large.
Because I have say 2 customers, just like this is a simple example. I have 2 customers and some items and then some reorder. Then you have to say, okay, both the customers come before I reorder. 1 customer comes and then this reorder. So there are so many different ways in which these concurrent things could be, sequenced. In addition to the fact that the actual list items have to be serviced and all that. So
It's tough.
It's very tough. It's very tough because we are, I think, not good at. Also, mentally, it's
Not good
hard
at
to keep track. Yeah, even when we are doing
multitasking.
even when we are doing 2-3 things at the same time, we tend to lose. That's why if we are not focusing on what we are doing, we tend to make mistakes because we forget to take one step. Or so it's equally tough to design these things. Of course, see, it will run. Once you have designed it, you've written the code, it will run. But have you taken care of all the situations in a acceptable way, or will it suddenly get stuck? And then
you get stuck and you don't know what.
See, because if you have not anticipated that a situation could come in a shop, customer comes to a shop and the item is not there, right? Then at this point your procedure will just get stuck. If you assume that all the items that are to be bought are there, it could also be that the customer has some alternative. He is asking for this type of soap and he is willing to take another type of soap. So that's also an option, right? So you could it could be specific to a type of brand, in which case the shopkeeper could suggest, I don't have this, but I have that. Will you take that instead? So you have to have this kind of things at the level of code. In real life, we know how these things are handled.
Actually, I mean, I've seen some very smart shopkeepers when they have many customers standing in queue in front of them. They try to service more than one customer at the same time by.
Yeah, because they do their own concurrency, especially in this kirana store, because it takes some time to go and fetch the thing from the.
So while you start taking
so the first guy is waiting for his soap to come, then he'll ask second guy, what do you want, right? Of course, then sometimes you get frustrated if you're standing there because you think that you are being made to wait. But generally the whole thing goes through much faster that way rather than finishing one whole thing, especially if somebody has a long list. That's also a big problem.
Correct.
If somebody has a long list, somebody is asking to buy 10 items and somebody got only 2 items.
One item or two items.
Then that person can actually come, finish and go while this guy is still. See, this happens in the supermarket, which you cannot, I mean, kirana store guy can do it. Supermarket, if you get stuck behind a guy with a full shopping basket.
You're finished.
Then it can be really slow. And then that same person will usually have forgotten things. So they'll run back to go and get more things from inside while their bill is being made. So,
but you'll have more than one checkout counter there.
Yeah, but usually then you look and see that somebody has joined that line. So now should I wait for this guy? And of course there's a rule, right? Whenever you switch, that other counter will get, whichever counter you move to will get slow.
So many possibilities, my God. This concurrency thing is really interesting.
But the thing is that in real life, this is what happens, right? We deal with these things all the time, and if we want to somehow make them happen automatically or mechanically. So if you take a kirana store and you want to put it online, right, then you have to deal with these issues. Right? You have to write code which handles all these multiple customers coming, asking for. So this is the same problem that you will face now if you are selling, say, flight tickets, right? I look at the flight and it says there is a ticket. You look at a seat. You look at the flight and you say there is a seat.
Or both of us try at the same time.
Both of us try to buy it, but actually there is only one seat. So only one of us is going to get it, right? But when we are looking at it, as long as nobody has tried to buy it, there is a seat. It doesn't tell you normally how many seats are there. I mean, train might tell you.
For this in concurrency, what do you call this? I mean, this is a situation where finally.
Yeah, so we are, in some sense, we are racing for this thing, right? So whoever gets to that seat first is going to get the seat, the other person is going to be disappointed. So this is called a race condition. So that. So this happens in.
But it may so happen that both of us go for the seat. The guy tries to block it. Both of us say, okay, the seat is not coming, so both of us get out.
Yeah, so that also.
The seat never gets sold.
Yeah, that's another situation, right? So yeah.
It happens, right? We both of us. I can start talking.
Yeah.
Somehow we figure out. When you talk, I keep quiet. When I talk, you keep quiet. Sometimes both of us start talking.
Yeah.
Or both of us are talking. So I stop.
Yeah. Or supposing there is a package deal, right? Supposing they are selling something where I offer you a flight and a hotel. Now it so happens that we book it together, I mean separate bookings, and there was only one hotel room and only one flight seat.
I got the flight, you got the hotel.
Yeah, and now I am waiting for somebody to release a flight seat, you are waiting for somebody to release a hotel room, and we are both stuck, right? We are waiting for each other, none of us is willing to give it up. So this also happens. So you have this deadlock, right? I am waiting for you, you are waiting for me.
Neither is getting what we want.
Neither of us is getting what we want, neither of us is willing to give up what we have. So we have to decide some policy to get out of this. So all these things come up in concurrency. When you are trying to, see, when we are dealing in real life, we make a decision which at that time, we might get into an argument or whatever, but we make a decision and we proceed. But code is not like that, right? So code has to be able to, otherwise if code gets stuck, it gets stuck. Nobody is going to come and
unwind it. Especially if it's concurrent.
Yeah.
3-4 guys maybe get stuck. Like for example, you said one guy's flight and one guy's hotel.
Yeah.
They are mutually stuck.
Yeah. So now
If it is a single program which got stuck, then I can kill this program and start it again.
yeah.
But we have 2 people, then I have to kill both of them. Huh?
Yeah.
So I don't know who all is stuck.
Yeah,
actually.
and then if you have, then you have your earlier problem that you get stuck, everybody comes back, you start again, everybody comes back, so nobody makes any progress. So at least you would like one person to go through with a hotel and a flight.
Yeah.
So ideally you should decide one of them should give up.
Somebody should decide.
Yeah.
It's an arbiter. Somebody,
Yeah.
some god comes in suddenly and decides.
Yeah.
You're the lucky guy. I give you both hotel and flight today. Huh?
Yeah.
Correct. This way. Very, very interesting. My God, so many complications. So many complications.